Here is a basic energy problem. We have a Snickers bar which gives us 250 calories of energy, and we have a man that is climbing up a ladder being fueled by this energy. We're making the assumption that all of the energy he consumes in the bar is converted to his energy moving up the ladder, which would not be the case in the real world, but we'll make that assumption for this problem. So we know that his Snickers bar gives him energy, and that energy is in the form of calories or food calories. He has 250 calories. We'll use the big C for calories. That's what a food calorie is. I'll write it out as my problem is, but we want to convert that because when we solve all problems, we want them in joules. And we know that based on our conversion that 1 calorie is 4.184 kilojoules, but we want regular joules, so we can convert kilojoules to joules, get rid of kilojoules, and go to joules. We know that as a basic metric conversion, there's 1,000 joules in 1 kilojoule. So when I do that conversion, I have a certain amount of energy is equal to 250 times 4.184, and I can move the decimal place or multiply by 1,000, and I get 1,046,000 joules. So that's how much food energy our climber has before he starts climbing the ladder. And he's going to convert all that energy to height. They're not talking about the speed of the climber. So he starts on the ground. Here's our climber on the ground. Here's our ladder. All right, so here's our initial scenario. And later he's elevated on the ladder a certain height. And at the bottom, the only energy he has is in food energy, which I haven't told you how to calculate, but we know the value, which is equal to 1,046,000 joules. And at the top, assuming he used all of that energy from the food to convert it to what we would have at the top, which is GPE, which is equal to his mass times gravity times his new height. And so we can set those equal to each other, the food energy equal to his change in gravitational potential energy. Write in what we know, 1,046,000 joules of food energy, and he has to have that same amount of energy at the end. In this case, it's all in GPE, which is mass times gravity times height. We know that his mass, given in the problem, is 78 kilograms, and G is just 9.8 meters per second squared. And so when we plug in those values, we're left with one unknown, which is the height we're trying to solve. So we're going to divide by 78 times 9.8 on both sides. That's going to cancel here, and we're left with a height. When we plug it into our calculator, I'm going to divide. I'm going to make sure I have parentheses so it divides by the entire denominator. And I get a height of 1,368. And because I'm dealing with joules, meters, kilograms, and seconds, then my answer for height should be in meters. Seems like a ridiculous value for how high you can climb on one candy bar. And again, not all the calories from the candy bar would be converted to energy that can be used to climb. Some of it will be wasted in the digestive process. Some of it will be wasted in heating the body and pumping blood through the veins. But some of that energy can be converted to climbing.